In this video, we're just going to do a few more examples using double angle formulas. Okay, so the first one is to establish the double angle formula for tan. And so I just want to remind ourselves, okay, so recall that we know tan of, not theta, of alpha plus or minus beta is tan of alpha plus or minus tan of beta over 1 and then minus plus tan of alpha times tan of beta. Okay, so remember these two are the same and this one is flipped. Okay, so we're going to want to use this identity here. Okay, so tan of 2 theta is the same as tan of theta plus theta. Okay, so that means that alpha is theta, but so is beta. Okay, so they're both equal to theta in the formula. So this is going to be tan of theta plus, because it matches, tan of theta again, over 1 minus tan of theta times tan of theta. Okay, so these two again match, whereas this one is the opposite. Okay, so that's how you use the formula. Now, tan theta plus tan theta on the top, that's 2 tan thetas. And on the bottom, tan theta times tan theta is tan squared theta. Okay, and you can see that that is the formula for tan 2 theta. So this was the left-hand side, and now we have attained the right-hand side. Okay, so that establishes the identity there. Okay, now we want to use these identities. Okay, so so we're given that, let's just go back to the example here. So we're given that cos theta is 3 over 5, and theta is in the interval from 0 to pi by 2, so it's in quadrant 1. Okay, we already made this triangle, but in fact we don't actually need any of that because we don't have to use sine theta at all. I mean, you can, because remember there's so many different ways to write cos of 2 theta. So cos of 2 theta is cos squared theta minus sine squared theta, or it's 2 cos squared theta minus 1, or it's 1 minus 2 sine squared theta. So you can actually use any of these to answer because we know sine and cos already. Okay, if we hadn't done part A, then you would definitely want to use this one because it's going to save you some work because you don't actually need sine theta. Okay, so if I wanted to use that one, it's going to be 2 cos of theta squared minus 1. Okay, and I know cos of theta, so that was given to me, is 3 over 5. Okay, so that is going to be 2 times 9 over 25 minus 1. So if I simplify that, it's 18 over 25 minus 25 over 25. I get minus 7 over 25. Oops. Okay, now if you wanted to use a different one, because we have done the signs, let's say we use the first one, so it would be cos squared, so that's 3 over 5 all squared, minus sine squared, which is 4 over 5 all squared. So that's going to be 9 over 25 minus 16 over 25, and again we get minus 7 over 25. Okay, same answer. So it doesn't matter what one you do. You can use any of the three. Okay, so we just did 2 of them. Okay, last example here. So we want to solve sine of 2 theta is equal to cos theta on the interval from 0 to 2 pi. Okay, so the first thing I'm going to do, so 2 thetas are hard to solve as we've seen before, and I want to have like a 0 on one side. Okay, so let's just move the cosine over. So it's sine 2 theta minus cos theta is equal to 0. Okay, now these are not related because it's a 2 theta and a theta. So what I'm going to do is use the formula for sine 2 theta. So that's 2 sine theta cos theta minus cos theta equals 0. Now I can factor out the cos theta that's in both, and I get cos theta times 2 sine theta minus 1. Okay, now the reason I wanted to set it equal to 0 is when I have two things that are multiplying, giving me 0, it means that one of them has to be 0. So either cosine theta is 0 or 2 sine theta minus 1 is 0. Okay, so that means cosine is 0, cosine theta, or sine of theta is 1/2. Okay, and then we just want to solve these. So I'm going to just draw a circle over here. Okay, so cosine theta is equal to 0 when the x value is 0. So that's going to be up here and down here. Okay, so I'm just going to put that in blue so we know that's where that happens. So this is 0, 1 and 0, -1. Okay, so that's the angle pi by 2 or the angle 3 pi by 2. Okay, so we get those two solutions. So theta is pi by 2 or 3 pi by 2 or any angle that's coterminal with those, but we're on the interval from 0 to 2 pi. So those are the only ones in that interval. Okay, now sine theta being 1/2, so you might know this one. Okay, if you don't though, theta is going to be sine inverse of 1/2. If you're in degree mode, it's going to give you 30 degrees, which you can then convert to be pi by 6. Okay, so that is right here. Okay, now so there's another solution where sine is also equal to 1/2. Okay, so remember this point here has coordinates, so the x coordinate is cos of pi by 6, and the y coordinate is sine of pi by 6, okay, which we know is 1/2. This one we also know. It's root 3 over 2, okay. So what we want is we want to find the other one with a sine value of 1/2, so that means it's going to have the same y value. So then it's going to be over here. Okay, so this is going to have the same y value of 1/2. The x value is going to be the same but negative. Okay, so that's also, so this angle here also has sine equal to 1/2. Okay, now the reference angle is going to be the same as the pink one. So that's going to be 30 degrees. So it's 180 minus 30, so 150, or 5 pi by 6. Okay, so that means that all solutions on the interval from 0 to 2 pi are pi by 6, pi by 2, 5 pi by 6, and 3 pi by 2. So I wrote them in increasing order, but obviously you don't have to do that. Okay, so those are our 4 solutions here. Okay, so this one, I don't know why I did 2 different colors, okay, but it's green and pink in the picture. Yeah, so that's how we would solve that. So we started by using the double angle formula so that we didn't have the double angles anymore. And it also enabled us to factor the equation, which gives us 2 smaller equations that we know how to solve. Okay, so those are some examples using double angle formulas.